Hey everyone! Welcome back to SciSpectrum Lab Essentials. If you've ever stood in front of a catalog trying to pick the right pH meter and felt completely overwhelmed, this video is for you. Today, I'm going to walk you through 10 things every laboratory should know before buying a pH meter, so you walk away with the right instrument for your application and never waste money on the wrong one again. Let's get into it. Here's the truth that nobody tells you. Buying the wrong pH meter is one of the most expensive mistakes a laboratory can make, and not just in rupees. You end up with poor accuracy, electrodes that fail every few months, calibration that feels like a daily chore, extra maintenance costs you didn't budget for, and worst of all, results you can't trust. The right meter pays you back through accuracy, reliability, and long-term value. It quietly protects every downstream decision your lab makes. So here's the plan. We're going to walk through 10 buying factors step by step. Application, accuracy, portable versus bench, temperature compensation, electrode selection, calibration, data logging, build quality, total cost of ownership, and technical support. Each one matters in its own way, and by the end of this video, you'll know exactly which ones apply to your lab. Let's start with the most important one. Factor 1, understand your application. This is where everything starts. A meter used for drinking water testing is fundamentally different from one used in pharmaceutical QC, food production, or cosmetics. Different samples need different electrodes, different sample handling, and sometimes different meter features entirely. So before you even look at a spec sheet, do this one thing. Name exactly what you're testing. Once you know your sample matrix, the rest of the decision gets much easier. Factor 2, required accuracy. Don't pay for precision your application doesn't need. Education work? Plus or minus 0.1 pH is perfectly fine. Routine QC? You want plus or minus 0.01. Pharmaceutical? 0.01 or better with full GLP features. Research grade work? High stability is the priority. Here's the thing. A higher resolution meter costs roughly 2 to 3 times more. If your spec only requires 0.1, that extra digit on the display is just wasted budget. Right-size the precision to the workflow. Factor 3, portable or bench. 2 form factors, 2 very different workflows. Portable meters are built for mobility, field testing, water plants, environmental monitoring, anywhere the measurement happens away from a lab bench. Bench meters are built for performance, research, QC, pharmaceutical work, anywhere you need high accuracy and continuous operation. Don't pick the one that looks more impressive. Pick the one that matches where your measurement actually happens. Let's put them side by side. Portable meters win on mobility, field use, and price. They're battery-powered, compact, and rugged. Bench meters win on accuracy, lab use, and data logging capability. If you're moving between sites or working outdoors, portable is the answer. If you're at a bench all day running batches, a bench meter gives you far more value for the money. Simple as that. Factor 4, automatic temperature compensation, or ATC. Here's something people forget. Temperature directly affects pH readings. The same sample measured at 5 degrees and at 50 degrees will give very different values, even though the chemistry hasn't changed. ATC adjusts the reading to a standard reference temperature, so your results stay consistent across hot and cold samples. But remember, let the electrode equilibrate to the sample temperature before recording. ATC helps, but it's not magic. Used wrong, it gives you a confidently wrong number. Factor 5, and this is the one most people underestimate, choosing the right electrode. The electrode is just as important as the meter. I'll say that again. A $1,000 meter with the wrong probe gives you $1,000 garbage. There is no one-size-fits-all electrode. General purpose, food, soil, pure water, chemical, viscous samples, high temperature, every sample type has a matching electrode design. Get this wrong, and nothing else on the spec sheet will save you. Here are 6 common electrode designs to give you a sense of the variety. General purpose for routine aqueous samples. Flat surface for solids like cheese or meat. penetration tips for food and soil, food-grade electrodes for dairy and beverages, glass body for aggressive chemicals, and low ionic strength electrodes for pure water. Using the wrong electrode is the single most common cause of slow, drifting, and unreliable readings. So pick carefully and keep a backup for the unusual samples. Factor 6. Calibration features. Easy calibration improves long-term reliability. Look for automatic buffer recognition, 2-point and 3-point calibration options, calibration reminders, and electrode diagnostics that report slope and response time. A meter is only as accurate as its last calibration. Meters that make calibration easy get calibrated more often and produce data you can actually defend in an audit. Target an electrode slope between 95 and 105%. Factor 7. Data logging. For regulated labs, the data trail is the measurement itself. You need internal memory, USB export, software for trend analysis, and GLP-compliant records with date and timestamps. And don't forget the timestamp. GLP requires an unbroken date and time chain on every reading. Verify the meter has a real-time clock with battery backup, so a power loss doesn't wipe out your audit trail. Factor 8. Build quality. If the meter will ever leave the lab, treat IP rating and drop spec as hard requirements, not nice-to-haves. Water resistance, dust protection, large readable display, long battery life, strong housing. These are the things that decide whether your meter survives year 3. A meter that fails on a wet plant floor costs you far more in downtime than a slightly more expensive rugged unit that survives for years. Plan for the worst day your meter will ever have. Factor 9. Total cost of ownership. The sticker price is just the beginning. You also need to factor in electrode replacement every 12 to 24 months, buffers, storage solution, cleaning solution, annual service, and spare parts. The cheapest meter isn't always the most economical. A meter that costs 30% more upfront but uses a longer life electrode and cheaper consumables is usually the better deal by year 3. Always compute TCO over 3 to 5 years. Factor 10. Technical support. A meter is a multi-year relationship, not a one-time purchase. Before you buy, ask 5 questions. Do they offer calibration support? Are spare electrodes in stock locally? Is there a service center nearby? Can they help you choose the right electrode? Are common parts on the shelf? Good after-sales support saves both time and money and turns a vendor into a real partner. Quick recap. Run every shortlisted meter through these 10 questions before you raise a purchase order. Application, accuracy, portable or bench, ATC, electrode, calibration, data logging, build quality, ownership cost, and support. If a meter checks all 10 boxes for your workflow, you've found the right one. If it misses even one box that matters to you, keep looking. Still not sure? Here's a simple decision flow. What are you testing? Field or laboratory? If field, go portable. If laboratory, ask whether you need GLP compliance. If yes, choose an advanced bench meter with full audit trails. If no, a standard bench meter is more than enough. That's it. 3 questions, 1 recommendation. And that's it. 10 factors, 1 decision, and a pH meter that fits your lab perfectly. If this video helped, hit subscribe, like the video, and comment your application below. We'll help you pick the right meter for your specific workflow. You can also visit SciSpectrum.in for the full range. Until next time, precision, performance, progress. Thanks for watching.